Hello, everyone. Hope we all are doing well today. Today we're going to be talking about Unit 2, Lesson 2, adding polynomials. So let's go ahead and dive right into it. We should already have learned a little bit about what polynomials are in our last lesson. And today we're going to be talking about specifically how to add them together. So let's go ahead and take a look at, for instance, example 1, where we're going to be adding together these two polynomials, a squared plus 2a minus 4 and negative 4a squared plus 3a minus 6. So the very first thing that we're going to want to do is we're going to want to line up our like terms together top down. The reason why we do this is so that when we combine our coefficients together by adding, it makes life incredibly easy for us. So what we're going to do is I've gone ahead and set these aside. We're going to take the first polynomial, the a squared plus 2a minus 4, that's right up there, and we're going to line it up with our other term that we're adding together with it, the negative 4a squared plus 3a minus 6. So once we get it lined up like this, we go ahead and just add the coefficients together. A squared plus negative 4a squared, well, that's 1, that's an implied 1 if there's nothing there. So 1 minus 4 is going to make negative 3a squared. 2a plus 3a is going to make 5a. And negative 4 minus 6 will just end up making, not negative 6, that should end up making minus 10. So let me go ahead and fix that real quick. There should be a minus 10 right here. Apologies. So let me fix that real quick. 10. Just for your notes and stuff. Fixed. Easy. Nothing too bad at all. So got that done. All right, so yeah, we should have our answer being negative 3a squared plus 5a minus 10. Again, we're just going from top down, just adding those together, and that's really all that there is to it. One thing I do want to mention in this video is understanding what a like term is. A like term has to meet two restrictions. The first restriction is that it has a like term with another like term has to have the same variables. That means, like, at least in this case, the a's. So like, for example, the a squared and the minus 4 are not like terms because they don't have the same variables. The second condition for things to be considered like terms is not only do they have to have the same variables, but they also have to have the same exponents. And you'll notice that we are adding together a squareds with a squareds, a's with a's, constants with constants. And that's kind of the idea, is that we are only combining those terms because they are like with each other. So hopefully that makes a little bit of sense. Let's go ahead and dive into a second example just to make sure that we really understand this. So let's say that we have adding together negative 3x minus y and 2x plus 4y plus 3. Okay, so what we're going to do is, again, we're going to line up our like terms. We have our x's and y's, and we also have this other polynomial. You'll notice, though, that it has this plus 3 here at the end, and this first one doesn't have anything like that. That's okay. It'll just be kind of just a blank spot right there, and it'll just drop down into our answer. So when we go to add these, negative 3 plus 2, that's just going to make a negative 1x, because, again, that variable is going to stay there. Negative y plus 4y, that should just end up being a positive 3y. And because there's nothing going on here, we just leave this as plus 3. So our answer, I'll move it over, will just be negative x plus 3y plus 3. Okay, nothing too bad. Nothing too bad at all. Let's try another one just to make sure that we got it. Let's say that we had w squared plus 2w minus 6 plus 3w cubed plus 3. Well, yet again, we're going to want to line up our like terms. I've gone ahead and set them aside over here for us. I'm going to move the first term, or the first set of terms, right here, right about there. Reason why I'm doing that is because you'll notice that this 3w cubed plus 3 it actually, like, this first one doesn't have a w cubed. So what we're going to do is we are going to make it to where this 3w cubed is sitting over here on the left by itself. And the reason why is because there's no like terms that are going to go into it. It's just going to be sitting out here. If there was a w squared in this term, we would put it right here, or a w or anything. But the only thing else that we have is this plus 3. So I'm going to go ahead and add in the plus 3 as well. But again, we're going to have that sort of large spacing, just like that. So you notice again this big blank space. It's because again there's no like terms in between the w cubed and the plus 3 that we would want to combine with these two, with the w squared or the w or the 2w. So we leave that blank and we just line up those like terms. There's no like terms for w cubed, none here, but yes here. So we get that all lined up. Once we get that done, we just add them up. Again, there's no w cubed, there's no w no w cubes, so that means that we just drop it down completely like so. So it just stays 3w cubed. W squared just drops to w squared. 2w drops to 2w. But we do have one thing that changes. The -6 plus 3, that is just going to become -3. So that's how we get that answer there. Cool. So hopefully that made sense. Let's take a look at one more example, and then we'll do a bit of a word problem to kind of get ourselves used to that. If we have 3p squared minus 1, and also -3p squared minus 2p minus 4, and we want to combine those terms, or rather add them together, rather. Again, we're going to want to watch our spacing here. So I'm going to go ahead and just sort of split it up like so. I'll have my 3p squared right here, and I'll go ahead and put my -1 or the -1 part at the end. Again, I have to do all this stuff on a computer, but you guys can do this much easier on like paper or something like that. So we have that spacing there for us. We're then going to go ahead and move in our other terms like so. And I'll go ahead and just adjust this over. Okay. Again, just making sure that our like terms are on top of each other. We have p squareds with p squareds, constants with constants, that type of thing. And again, there's a blank here, but that's okay. That just means that it just effectively drops down for us. All right, so we're going to go ahead and start adding our like terms. 3p squared minus 3p squared. If we end up with just 3 minus 3, we're going to get 0. And 0 times p squared, that whole term just goes away. Because, again, when we multiply by 0, it just basically eats the term. So in this instance, the p squareds effectively vanish from our answer. We drop the -2p down, like so. And -1 minus 4, if added together, is just going to become -5. So our actual answer is just -2p minus 5. And that's it. Alrighty then. So hopefully adding these together seems pretty easy so far. Let's go ahead and take a look at a bit of a word problem. In this case, we're trying to find the perimeter of our figure. We have these different side lengths here. Again, the exact same process. We're just adding up, if we recall with perimeter, we're just adding up all the outer edges. So we're going to start by adding these up. The first thing, I'll go ahead and just start moving them around. You'll notice that we have x cubes, we have x squareds, x's, and constants. So we're going to want to watch our spacing here. So I'm going to sort of space these out a bit. I have my 3x cubed. I'll put that right there. I have a +2 that I need to care about as well. So I'll go ahead and grab that. And I'll just put that like right here at the end. I can move it if I need to. Then we have to deal with this 3x plus 1. The 3x plus 1, again, I'll just sort of break up. Actually, I don't even need to break it up, do I? Nope. Because I can just move it right here and just put it at the end. By the way, I haven't mentioned it yet, but something that's very important with any word problem when we're talking about units is that we want to make sure that those units are actually accounted for. So in this case, we're working with the distance of inches. We will want to make sure that that is held true in our answer and all of our work throughout. So we want to make sure that we don't forget about them. It's very important. Then we'll go ahead and get the other set of terms that we need to have, like that. and then our x cubed. I'll just go ahead and move up a little bit closer. So it's like that. So we have our x cubed, x squareds, x's, and constants. You want to get all of those things lined up. There's going to be some weird spacing sometimes, but that's okay. That's just a part of it. All right, so we go ahead and we get all that done. Our final answer will be this right here. The 3x cubed just drops down. The x squared just drops down. The 3x minus x becomes plus 2x. And something odd happens here. Our constants effectively just cancel out. We'll have 2 minus 1 minus 1. So 2 minus 1 minus 1 is 0. So it just goes away. All right, so that means our final answer is just going to be the 3x cubed plus x squared plus 2x inches, and that's why I'm doing all this right now. We want to make sure that those units are actually accounted for. So I hope this helped you out, guys. If y'all have any questions, let me know. Y'all have a good one.